whether it's concept drift, feature drift, prediction drift, with all these different kinds of things, the issue is that the model is no longer, for some reason or other, something about it is no longer relevant to the real world data that are coming through your platform.
These models inevitably drift. So there's issues with the baseline data versus the incoming data. There's performance degradation issues. These models are always going to change over time, but it's important to know how much they're changing.
I usually try and break down ML observability into this simple equation, which is it's monitoring plus the ability to identify the root cause of the issue. Just to know that something's gone wrong is not always enough.
Amber and Xander, two guests, double the fun, no doubt. Where are both of you calling in from?
So I'm calling in from the Miami area in Florida.
Mm-hmm. Nice.
I'm calling in from the San Francisco Bay Area in California.
Oh, nice. All right. Well, great to have you both on the show. I met Amber in person a couple of weeks ago at the time of filming. I was at ODSC East. I did a couple of half-day trainings there. I did a half-day training on deep learning, like an intro to deep learning with PyTorch and TensorFlow. And then I also had a half-day training that was a huge amount of fun for me to deliver, a huge amount of work for me to deliver because I hadn't done a talk on this content before, but it was on large language models, so natural language processing with LLMs, and specifically focusing on how we can be using both the commercial APIs like OpenAI's GPT-4, as well as open source models through Hugging Face, and then taking advantage of these kinds of tools together with PyTorch Lightning to efficiently train in order to have your own proprietary LLMs that are very powerful and kind of GPT-4 level quality. So I was talking about that stuff, and I lamented over lunch to Amber that I wish I had seen her presentation the day or at any time before I was presenting, because I had a slide on issues related to deploying LLMs. And I listed a whole bunch of problems that can happen in production. And my final bullet was there are various ML observability platforms out there. And I didn't list any because I didn't have any like particular one that I thought was like really good. I was like, I just said to the audience, go ahead and Google it. Oh, and by the way, all of that talk should now be live on YouTube by the time that you hear this, listener. It isn't at the time of recording, but I'm pretty confident it will be published and on YouTube if you want to check it out. So you can hear me lament about that. And yeah, so Amber did a talk specifically on model observability, machine learning observability with LLMs.
Mm-hmm. Yes. Yeah, that was a lot of fun, that conference. I did a talk on kind of LLMs in production. So LLM ops, and where Arize focuses on is the ML observability component. So ML observability is the software that helps teams automatically monitor AI, understand how to fix it when it's broken, and ultimately learn how to resolve the issues teams are facing in production. And LLM ops and LLM observability, similar concept to machine learning observability, but focused on these large language models.
Right. So I guess there are unique challenges related to LLMs in particular. Maybe we can dig into that in just a little bit. In the meantime, yeah, you can let us know a bit more about why, whether it's an LLM or not that we have in production, why is a machine learning observability platform like Arize useful to a data scientist, a machine learning engineer, or a business that's deploying a machine learning model?
That's a great question. And mostly it comes down to what you do after you develop this model that, it goes through all the tests in a Jupyter notebook, it looks great, and then you put it into production. Because I think I polled the audience during my talk, like how many people have put a model in production on a Friday night and then come back on Monday. And it's just, you don't want to be doing that because these models inevitably drift. So there's there's issues with the baseline data versus the incoming data. There's performance degradation issues. These models are always going to change over time, but it's important to know how much they're changing. Is that affecting customers? Is that affecting revenue? Is there fairness and bias issues thrown in there? Are there data quality issues? So there's a lot that comes into play in that post-production workflow. And oftentimes, what we see, Arize does a lot of surveying for our customers and for ML engineers in the space. And what we find is that 84% of teams say that it takes at least 1 week to detect and fix an issue in production. So sometimes these issues could exist as long as 6 months, and it's customers calling to complain like, hey, I'm not happy with the recommendations I'm receiving. I don't like this plan. I don't like this this feedback that I'm getting. That's really the last thing you want, is for you to find out there's a problem because customers, or you find it out because something's wrong with the revenue, something's wrong with the model. So just making sure you have the orchestration in place to prevent all these issues and to catch them early. It's that time to value that really makes teams want to purchase an observability solution like Arize.
Nice. That makes a lot of sense. So you talked about drift there. I know that in particular is something that is an issue with machine learning models in production that happens all the time. So what is drift? Why should we monitor it?
Another great question, John. And Arize does have 2 free courses. They're virtual certification courses that can be done at your own pace. And Drift is covered in both of those units. One is kind of an introduction to Drift, and one is the advanced Drift metrics that are used in production. And I would say it comes in kind of 2 categories. I'll let Xander tackle the second category. The first category are the structured use cases that we see. A lot of times you're looking at distributions and how distributions change over time. So you always have a reference or baseline distribution, and then you have a production distribution. So if you have your baseline distribution, let's say that's your training, and then your production data is going to be your current distribution. You're looking to see how that data is changing over time. So you can use a statistic method like PSI, which is a population stability index. You can use KL divergence. You can use a chi-squared test. There's a lot of different statistical methods that you can use to see how much one distribution is changing from another distribution. And so there's methods around that. And then for drift, it's important to set monitors, because you might have maybe certain features like user ID. User IDs are going to drift. That's totally fine. But if you have something like, say, number of states, you want 50 states. If that's what's used in your training model. And, we have seen teams that, maybe they get, now there's 60 states coming in, and that's because we trained our model on uncapitalized data, and now we're getting capitalized data coming in. So setting those monitors is going to be key. Xander, do you want to talk about how we measure unstructured drift in production?
Yeah, sure. So I can talk about the unstructured case. When you're dealing with unstructured data, what you're dealing with are embeddings. An embedding just being a vector representation of a piece of data. So imagine imagine you're dealing with like an image classification problem. You've got this image classification model. It's taking, photographs, and it's trying to tell you what's in the photograph. An embedding vector would just be this vector that's basically encoding similar images nearby in the embedding space and dissimilar images far apart. So you would want to see images of the same class nearby, dissimilar images far apart. And it's not just like, what is in the image. It's like these embedding vectors actually contain a lot of different kinds of information that you might not expect. Like, is the image grainy? Is it corrupted? Is the semantic content of the image changing? It can be really subtle things, actually, that are difficult for human beings to detect. And basically, what we do is we monitor the distribution of the embeddings, training relative to production. So is that distribution of embeddings in production, is it different from the distribution of embeddings that we saw in training? And if it's helpful, I can talk about exactly how we do that. But the basic idea would be, are you getting basically new areas of your embedding space? Are you seeing new parts of the embedding space light up in production that weren't represented in training? And for traditional models where you actually, a traditional CV model where you're actually training, you're training it on some data set, you could really expect that the model is not going to perform well if it's doing inferences on data the likes of which it never was trained on. So that's, in a nutshell, what we're doing when we detect embedding drift for unstructured cases. And I would emphasize, right, like that approach is actually very agnostic with respect to the kind of data you're representing. I was giving CV as an example, but you could also represent a piece of text as an embedding vector. You could represent, a piece of audio as an embedding vector. So it's a pretty agnostic approach to detecting drift for unstructured use cases.
Nice. So with structured data, with quantitative numbers that you'd find in a table, we can use what Amber was describing, where we just have some baseline distribution that we should be expecting. And if the distribution of those numbers in the table starts to get away from the baseline distribution, then that could set off like an alarm, basically. Is that what happens? Like somebody gets like a pager duty notification kind of thing?
Yes, so you can set your monitors, and that's where a lot of teams have difficulty. It's not so much understanding how drift works, but understand how to do it at scale. So what Arize does is set monitors for every feature of every model versions, of every model type. So you're able to handle it at scale, and so teams can work in Arize accounts similar to how you can use role access in Google or AWS, and work on different sets of models. And then, that goes to Slack, email, PagerDuty. Anytime a particular feature goes off on performance, drift, or data quality, that would be alerted to a team member.
This episode is brought to you by Posit, the open source data science company. Posit makes the best tools for data scientists who love open source, period, no matter which language they prefer. Posit's popular RStudio IDE and enterprise products like Posit Workbench, Connect, and Package Manager, these all help individuals, teams, and organizations scale R and Python development easily and securely. Produce higher quality analysis faster with great data science tools. Visit posit.co, that's POSIT.co, to learn more. Nice. Makes perfect sense. And so just kind of circling back to what Xander was saying there. So with tabular data, just like straight numbers that we can put in a distribution, we compare the baseline distribution to some production distribution. With unstructured data, whether it's images like the computer vision example that you gave, Xander, or whether it's natural language data, it could be audio waveforms, any of these unstructured data types, they can be converted into an embedding, which is just a vector of some length that represents numerically kind of an abstraction of all of the various features. So like you said, with computer vision, like it could be, is the image grainy or not? Or is the meaning of what's in this, is the semantic meaning that's represented by this image different? And so there would be some set of embeddings. So similar to the way that we have like a baseline distribution, and we're comparing that with the production distribution, we have this like baseline set of embeddings. And if we start to see embeddings that are far away from what we were expecting, then that similarly sets off an alarm.
Exactly.
Nice. All right. I think I'm following along. So I know that there are like lots of different kinds of drift. So I know there's like data drift, model drift, others. Are you able to like break down for us what these different kinds of drift are?
Yes. And I will say like the course gets into each type of drift, what it is, how to monitor it, and then what metrics you should use. There's definitely more details if people are interested in the course. But so different types of drift that we see what's known as kind of model drift or a drift in predictions. So if something's drifting in predictions, you don't need the actuals, you don't need those ground truths. But if you use something called concept drift, that's a drift in essentially the outputs, which means you do need that ground truth. And for teams that get the ground truth back without a really strong delay, it's better to use a performance metric, because what teams want to use drift for is a proxy to performance. So if they don't get that performance back, they want to see like, is anything happening? And so a lot of that comes with covariant drift, feature drift, data drift, metadata drift. All those are essentially putting drift monitors on each feature. And you can set those for numeric and categorical features. So the different types of drift we see are going to be around the features, the inputs, the outputs, and then there's also something known as upstream drift, which is essentially like something going wrong in the upstream process. So it's more likely an engineering issue that's coming around there. But yeah, I would say that the number one type of drift that teams care about is feature drift, because some of these models have thousands of features. And if you're using things like SHAP values, feature importance values, you might notice that maybe 5 features have the most important impact on decisions. And so they really want to monitor the most important features that are leading to these decisions that are then impacting customers. So feature drift is, I would say, one of the biggest ones. And PSI, which is a population stability index, which is actually derived from KL divergence, tends to be the most used metric because of like the stability it has and a symmetric property that KL divergence doesn't have.
Cool. Yeah. And so KL diversion, you mentioned a couple of times there. So Kolbach, I'm butchering the
Yeah,
pronunciation,
Kolbach.
Kolbach Leibler divergence that people can look up in full later. But just, I think when we say it really quickly in a podcast like KL, you're probably like, is that a word?
Yeah.
So two letters capitalized, KL hyphen in between them in many cases. KL divergence, so folks can look that up.
And we have, like I said, I mentioned the course, but we have blog posts that really go into detail as well. Yeah, I have trouble pronouncing it because there's JS, there's there's a lot of different abbreviations, and they're not the easiest to say, and they're even harder to calculate sometimes. So having like a go-to guide has been really helpful and has helped, I think, a lot of our customers understand it because these are non-trivial uh, things to calculate for large models.
Okay, cool. So I guess with a platform like Arize, does it come built in with like these kinds of calculations? So yeah.
Yes. So if you were to sign up for the Arize platform, which you can, Arize has a free version and you can upload 2 models into it. It's based on inferences. So anyone can go and try it out today. We have automatic schema detecting capabilities. You can upload your data from a CSV or cloud storage or an API. So a lot of different options for uploading your data. And then we'll automatically set all your monitors around drift performance and data quality. You can use custom metrics. We have a lot of default metrics that tend to be the most useful for teams. And so we have normally 2 types of customers. One type of customer that just wants everything done for them. They want to check on it maybe once a week and make sure that they're getting alerted when things happen. And then we have another type of team that really wants to dive in to fully understand all the features of their model, see if they can improve performance by 1%. Like what would it take to do that? But yeah, it can be as easy, automated as you'd like, or you can make it as configurable as you want. Like you can take away all the automated monitors and make everything customizable if that's what you want.
Nice. All right. I'm starting to get a full picture of the
Yeah.
shape of this platform and how to use it. So, we're uploading CSV files, so that the platform can get a sense of what our data are like. That allows it to create these kind of baseline distributions or baseline embeddings. And then we can be monitoring in production. And if some production issue happens, then there's alarms going off, emails, texts,
There's
PagerDuty
alarms
alerts.
and there's where we're pointing the finger. We're saying this is where it's happening in your data.
Mm, mhm.
And then what we're also able to do with some of our unstructured capabilities is export the data as well. So I think Xander's going to be talking more about our open source offering, which the capabilities there are also what you get from the Arize platform and our unstructured. But with all the clustering and the unstructured data, you can actually lasso certain points and export them. And teams can use this for labeling, retraining. But essentially, teams want to know where in the data the problem is and be able to see exactly how much that data is influencing the platform. So you can isolate, you can filter on those, whether it's metadata, whether it's a certain class, whether it's just a few like IDs, it's a location. You could filter on each one of those and see how much it's actually impacting performance. Like, is performance going down 2% when we isolate this data? So it's that isolation aspect that is the difference between ML observability and ML monitoring, because ML monitoring is kind of like the tip of the iceberg. Like, you definitely need that, but if you want to actually avoid these models going down, you need to have that second set of saying, where is this problem and how do I solve it?
Got it. Yeah. So that is, I guess I wasn't in my head aware that those two words weren't synonyms. So
Mhm.
I might have thought that ML monitoring and ML
Yeah.
observability were the same thing. But okay, so ML monitoring is like somebody could have a we could have a screen in the office with like a bunch of charts of like performance over time or these distributions over time and how they're changing, but that requires somebody to be like keeping an eye on it. And you're like, uh-oh. But with ML observability, it's automatically keeping an eye for you.
Right, right. And when you mention those screens, it makes me think of like the stock market and stock exchange, and you'd have everything going on. And unless you're constantly looking at it all the time, just having something in place like a stop limit, so what's happening, when you know where your limits are, and so you could set those for your models. Like,
Mm.
anytime this goes down 2%, it affects our KPIs, our profitability goes down $10 million. And so relating those to business metrics, you can
Mhm.
have those in place.
Yeah, it's interesting that you said stop order because that is like, are you saying that from like experience in financial markets, or is that actually what you also call it in your platform?
No, I just came up with
Yeah.
that from how you were visualizing it for me.
Yeah, yeah, no, exactly. But yeah, that was perfect. And it was so fluid that I was like, and hey, that's actually just how they like configure it. But yeah, so it's like, yeah, how do you know that? I didn't notice that you had a trading background from your biography
I
or,
don't. Yeah.
oh, yeah,
COVID
but
hobbies.
but yeah, that makes perfect sense. So that like, yeah, if you're expecting some asset that you can set it up so that in real time with a lot of these trading platforms that if something hits a certain price, you'll either automatically buy or sell. And yeah, that makes perfect sense here. It's like the if some aspect of your model in production drifts so far that it hits this like price that it triggers, it's like, that change corresponds to, yeah, this business impact of this amount of dollars lost. And so at that point, we've got to be sure that we're on top of it and that it's worth like, uh, yeah, that sequence of whoever's PagerDuty things are going off in the middle of the night, so that someone has to get up and fix it.
Yeah, a lot of times it will trigger a retraining cycle.
Nice, which is actually one of the topics that I wanted to talk about next because when something goes wrong, when like an alarm goes off, when a model is no longer performing like expected, because that like fundamentally that's the idea with drift. If we were to like summarize it, whether it's concept drift, feature drift, prediction drift, with all these different kinds of things, the issue is that the model is no longer, for some reason or other, something about it is no longer relevant to the real world data that are coming through your platform. And so then when this arises, we need to retrain our model, I guess is the most common solution.
Retraining is a very common solution, and I'll actually let Xander chime in on this because he works a lot with community members that are leveraging Arize for their use cases. But retraining is very common, but a lot of times, it's a bigger conversation of what's going on with the data. I never realized how strange it was to retrain a model on an arbitrary amount of time until I started working at an ML observability company. And then, oh, we're going to retrain every 2 weeks or every day or every 6 months. Like, you realize that really doesn't make sense. It should be on a needs basis. But Xander, like, what
Oh,
have you seen
interesting.
with the community?
Yeah, so just really quickly, Xander, before you go, that is a really interesting point that you made and something that I have never thought of. So for me, it's this uh, I've only ever thought of model retraining. Indeed, in my talk at ODSC East in Boston, I specifically was like, yeah, you need to retrain at regular intervals. Is the exact guidance that I provided on my monitoring ML models in production slide, which now I realize it says monitoring ML models in production. And so, yeah, I hadn't gone that step further and been thinking about like observing. But so I guess as part of this with observing, you can be having these triggers automatically retrain your model, which makes more sense for so many reasons. Because if like from my suggestion, it's this like daily, weekly, monthly, whatever cadence on retraining the model, and that actually doesn't make any sense unless you're aware of how much drift is happening. Because if I'm doing it every day, but I only need to be doing it once a year, I'm wasting a crazy amount of resources.
Yes.
Whereas if I'm only doing it once a year and I should be doing it every day, my platform is going to be terrible.
Yes, exactly. If it isn't broken, the saying goes, you don't need to fix it. And then you do have teams on the other side that are afraid to retrain a very large model that cascades into maybe 10 other models that affect 10 other teams. And if they retrain it and something goes wrong, so you have people on both ends. They're like, let's retrain every time we get any new data. And then teams that are, let's be very, very cautious and not retrain unless it's absolutely necessary. And Arize helps folks understand when is the right time to retrain.
Awesome. All right. So Xander, I didn't let you speak earlier. You got some examples for us?
Well, yeah, I think just one thing I wanted to add on to what Amber's already said, just around the difference between ML monitoring and ML observability. I usually try and break down ML observability into this simple equation, which is it's monitoring plus the ability to identify the root cause of the issue. So just to know that something's gone wrong is not always enough. Like you need to actually have some visibility into what's causing the problem, and figuring that out for machine learning systems can actually be like this really devilishly tricky problem to do. And so I think that's also one of the distinctions I draw there between those two concepts. Part of what we're trying to do is not only just detect and give you a little alarm bell, but also to help you really quickly, to give you these like opinionated workflows that are going to really help you quickly identify exactly what the issue is. So that's another differentiator I would say, like between monitoring versus ML observability.
This episode of Super Data Science is brought to you by AWS Trainium and Inferentia, the ideal accelerators for generative AI. AWS Trainium and Inferentia chips are purpose-built by AWS to train and deploy large-scale models. Whether you are building with large language models or latent diffusion models, you no longer have to choose between optimizing performance or lowering costs. Learn more about how you can save up to 50% on training costs and up to 40% on inference costs with these high-performance accelerators. We have all the links for getting started right away in the show notes. Awesome. Now back to our show. Cool. All right. Yeah. Thanks for that additional insight, Xander, on ML monitoring versus observability. And so thus far, we've been detailing the Arize commercial platform and how it can be useful. And you even mentioned how people can be having up to 2 models uploaded for free, which is super cool. So people can check it out. And maybe for like, smaller companies or use cases, that'll be enough for them actually without needing to go to a commercial option. But you also have a brand new open source product, which is called Phoenix. So tell us about Phoenix. Can it do everything that the Arize enterprise product can do, for example?
Yeah, so Phoenix is bringing part of the functionality of the Arize enterprise platform, which is the SaaS platform. It's bringing part of that functionality into a notebook environment. So what it actually is an application that runs alongside your Jupyter notebook, runs on the same server that's running your notebook server, whether that's your local computer, whether that is your Colab server. And it actually gives you this interactive experience that's more immediate than uploading data to a SaaS platform. And right now, at the moment, it's really focused on unstructured data, on the unstructured offering that I talked about a moment ago. But I think in terms of the long-term scope, we're really trying to be responsive to the community. What does the community want? What is the community hungry for? And right now, the answer is they're really hungry for LLMs. So that's really like where the push is happening for us on the Phoenix front right now.
Awesome. Yeah. So, I mean, tying back in perfectly to a lot of podcast episodes that we've had recently on the show, we've had a lot on generative AI, on large language models. Obviously, like my talk at ODS East was focused on that and was a super popular one. And I knew it would be because this is just like what everyone's talking about, whether you're in data science or not, and whether you know to call it large language models or you know to call it generative AI, everybody's talking about ChatGPT, GPT-4, Midjourney, and how these large language models are impacting the world. And is my job safe, or like how is this going to change things in the future? What are the policy implications? What does this mean for misinformation? So yeah, so like one way or another, in the data science world or not, these are major topics. And so it's really cool that you have decided to go to be kind of LLM first, unstructured data first, with your Phoenix open source product. So yeah, so I mean, is this something like people just go to the GitHub repo and it's like straightforward how to be using this with your LLMs?
Yeah. So you can just pip install it. It's pip install Arize-Phoenix. You can check out our GitHub repo. You can check out our docs. We got a bunch of tutorial notebooks up. Yeah, so it's free to get started. Just put it in your notebook and run it.
Nice. And then like, are there additional kind of resource requirements? Like I guess if we already have so typically to be running an LLM, we'd need to have some pretty big infrastructure running, probably with at least one GPU. And then so I guess in addition to that, there's probably no additional like infrastructure requirements. It'll be relatively lightweight relative to the model.
Yeah, there's no infra requirements at all. You can run it along, if you're running in a notebook environment that has like a GPU, you can run it there, but you don't need a GPU in order to run the app.
Of
The
course, of
app is
course.
just this pretty lightweight application, and it actually is going to be a UI that you can actually use either in a separate browser tab, or literally you can open up the UI and use the application literally inside of the Jupyter Notebook.
Gotcha. So once you get Phoenix running,
Mhm.
yeah, it allows you similarly to the way that you might have Tensor board running
Yep.
for watching your machine learning model train. Whether TensorBoard comes originally from TensorFlow, but your model could be in PyTorch. It doesn't matter. With TensorBoard, you can open up another browser tab, or again, you could have it running just there in the notebook, and you can watch your model's cost hopefully go down as your model trains. And so similarly, you could have another tab open with Phoenix running, and
Mhm.
so you could be watching in real time as your model's running in production. Just have this extra tab open, and then that sounds like ML monitoring to me so far.
Mhm. Mhm.
So, but Phoenix also has built in like the observability component that if we hit that, to go back to the financial algorithm, if we hit that stop order price, we'll end up triggering alerts.
Oh yeah. Oh yeah. So one thing I'll say is like Phoenix at the moment is not real time. If the community, if we find that the community wants
Oh,
that,
gotcha.
we could
Gotcha.
put that in.
Gotcha.
But at the moment, it's not a real time application. That would be the SaaS platform, right? But imagine that you've got some inference data, right? And imagine that we're in this situation where we want to detect drift. And before I mentioned, you're monitoring your embedding distribution, right? And we're able to actually measure quantitatively how far has the production distribution drifted away from the training distribution of embeddings. And so you can imagine you've got like this graph showing you drift of your production data relative to your training data over time. Again, all of this is the drift of the embedding distribution, right? And then what we can do is like we can take those embeddings, and this is where I wish I could show the people who are listening, but imagine this, like imagine you take the embeddings, which are these high dimensional vectors, right? They could be 1,000 dimensions or more, right? And you take those embeddings and you do some dimensionality reduction to view them in 3 dimensions. So now you're actually literally able to see your two embedding distributions in 3 dimensions, your production and your training distributions. And again, like I mentioned, like if the production distribution is trained has drifted away from that training distribution. Again, you're going to be seeing pockets of production data that you didn't see during training. So it's really cool. You can like literally see the exact data points in production where you didn't have training data. And
Gotcha.
then what we do is we provide this. Yeah, go ahead.
But this is all Phoenix that you're still describing, right?
So this is Phoenix, but this is also in the SaaS platform.
But so like this is going to sound, I must like have missed something. But so you said Phoenix doesn't work on production, but everything that you were just describing was like production embeddings and comparing those to training. So like, yeah, so like so like when we're watching Phoenix, when we have this extra tab open as we're training, like what are we watching? Like what are we, like you were talking about it as like comparing production embeddings versus training embeddings, but like I wouldn't have, like if we're just training a model, what does production embeddings mean in that context?
Yeah. So I think I was probably, I was just trying to say like, it's not, I was trying to clarify like Phoenix isn't an app that you're like logging real-time data to, if that makes sense. It would be like, imagine you've got
batches of production data.
Yeah.
So you can still have batches.
Oh,
Yeah.
I see. So, okay. So I completely misunderstood. So I was thinking that Phoenix was like, I was then now like, okay, I have two tabs open. I've got my tensor board running, and maybe this is like, it's my mistake because I was just kind of like running with this idea. But like I'm training a model in my Jupyter notebook, and I've got a tab open that I'm watching like my loss functions on, and then I've got another one where I'm watching Phoenix. But that isn't what you'd
Not
be doing.
quite. Not quite.
You're taking batches of production data and ad hoc looking at them to check for drift. So Phoenix allows you to do ad hoc ML monitoring to identify like your own issues and to see like to give you a better understanding of maybe where your model's starting to fall down in production or where it has limitations, and where you might want to be retraining or adjusting aspects of your model architecture.
That is an accurate description. Yeah.
Yeah, and John, you can also use like a validation set versus a training set. You can use it pre-production, but most folks are concerned with that post-production workflow.
Right.
Even if the inferences are kind of like mock data, most of the time it's like you get a little bit of data back, you're kind of A/B testing, you're getting some information back just to see how well your model is doing. Right, we're not just like validating the model, we're validating how well our model is doing with our customers.
I gotcha. And so and so you made a really interesting example there, Amber, that I hadn't thought of, which is splitting our training and validation sets. So um, I'm guessing, you can correct me where I'm wrong here, but it sounds to me like when we are training our models and we want to make sure that our model works well on data that it hasn't seen before, we have this validation data set that we set aside. But that validation data set is only useful if it matches our training data in terms of obviously not being identical data points, but having the same kind of distribution in the case of structured numeric data, or the same kind of embeddings in the case of unstructured data. Yeah, I got some head nods, which only our video version actually, and my head would have been on screen, so you couldn't even see. But Xander and Amber both nodded their heads in agreement at the same time. So okay, cool.
And,
yeah, that's another use case that I hadn't thought of.
And I would just add on to that, right? Like I think I started out with this idea of training versus production because I think that's a lot of the time the easiest one to understand the very first time. But in general, Phoenix is this pretty general tool for being able to diff embedding distributions, right? So as you mentioned, you could be diffing the distributions between training and validation data. You could be diffing the two distributions between a fine-tuned and a pre-trained model. You could be we're getting into like actually really interesting applications right now. So actually what I've been working on the past couple of weeks is diffing the distribution of embeddings for a context retrieval knowledge base versus the distribution of user queries to understand, are users asking my llama index service or my LangChain semantic retrieval service, are they asking questions of my database that are answered in the database or that aren't answered, right? So it's a pretty general idea. It's like really like champion challenger, anytime you would want to diff to embedding distributions, I would say.
Nice. Great. Thank you for like generalizing this concept as well
Yeah,
as then
yeah.
giving specific examples. Very cool. So yeah. So the canonical thing that we're thinking of with ML observability in general, because this is the thing that, we're worried about most in production, is comparing training data distributions versus production.
Yeah.
But of course, a tool like Phoenix, which is open source, which we can use for comparing any kinds of embeddings, we can be using that for comparing our training data versus validation data, fine-tuned model versus not. Particular user use cases, making sure that trying to see whether users are kind of using our platform in the way that we anticipated, the way that we trained it for. Super cool. All right.
Yeah.
I'm starting to see a huge amount of value here in Phoenix. And so I guess so you mentioned how you developed Phoenix on the one hand because LLMs are so popular today, but I just had a bit of a brainwave, and you can correct me if I'm wrong on this, but it seems to me like that it might also be particularly useful because of how for comparing embeddings, this is so much more complicated than just comparing distributions. So it also kind of seems like you've created a product that solves like the more complex problem. With respect to we talked at the beginning of the episode about like structured data where we're just comparing distributions versus unstructured data where we're comparing embeddings. It seems to me like that latter problem is more complicated, and so this Phoenix problem like scratches that complex itch.
I think that's a good description. And then I think one last thing I would tack on there too is again, like, the thing that we're really aiming to do is not only detect like that something's changed, but is really to immediately drill down into exactly what has changed. Um, so like what that looks like in the product is uh, we're actually like pointing out the exact portions, the exact embeddings, the exact data points that are causing the drift or that are causing this change in the distribution, and then surfacing those up to the user and telling you this is what you need. This is the data that you need to look at in order to understand why you're experiencing this drift issue, or in order to understand why are the users who are asking questions of my you know my semantic retrieval LangChain service, why are they not getting answered, right? That's the idea.
And the whole of Arize products are to solve the pain points our customers are facing. So the problems that customers have with using traditional drift methods aren't so much being able to like understand how it works, but being able to do it at scale, being able to do it with very high volume, being able to select which metric is best for that use case. And that's what we help solve for more traditional drift metrics, like setting them up for scale. And then for unstructured, is this even possible? Like a lot of teams are coming to us that have more traditional models, and they're like, I'm thinking about using these LLMs now. Like I don't want to be behind. How would that even look? Can I track that? Can I see how that's doing in production? And so those are just some of the ways we look at it, and like some of what sets Arize apart.
Nice. Very cool. Did you know that Anaconda is the world's most popular platform for developing and deploying secure Python solutions faster? Anaconda's solutions enable practitioners and institutions around the world to securely harness the power of open source. And their cloud platform is a place where you can learn and share within the Python community. Master your Python skills with on-demand courses, cloud-hosted notebooks, webinars, and so much more. See why over 35 million users trust Anaconda by heading to superdatascience.com/anaconda. You'll find the page pre-populated with our special code SDS, so you'll get your first 30 days free. Yep, that's 30 days of free Python training at superdatascience.com/anaconda. So when we're dealing with LLMs, the scale of these models can be very large, obviously, like billions of parameters. And then so when we think about uh, a user of your products, maybe having a very large LLM that also has a lot of users, so like they're needing to scale up, already big servers to, to very large numbers of these servers running, to be handling all the users. So, are there considerations? Are these kinds of scale challenges something that the Arise team had to deal with as, um, yeah, as you guys decided that LLMs was something you wanted to focus on, or did it? Is there something about the way that Arise was architected that the scaling just kind of happened automatically?
Xander, do you want to take a crack at that first?
Yeah, I think I want to also maybe clarify one thing that I think is a common question we get in the beginning, which is like, what data is Arise actually taking in? So we're
Right.
not actually taking in the model. We don't ever we never, we're not an inference platform. We don't take in
Right.
the model. We're not performing inferences. That
Right.
that is our customers who are actually handling that responsibility, and our customers are logging to us basically all of the data around the inferences. In the case of an LLM, you're going to have the actual embedding itself. So you as the customer would, at inference time, grab that last hidden layer, or however you want to construct that embedding, and you would log it to us, right? um, and then we're taking in that embedding, and that is the information that the Arise platform is actually responsible for.
Gotcha, gotcha. So it sounds like the answer to my question is that, yeah, it Arise scales very easily. Like it's yeah, got it, got it,
Yeah.
got it.
Oh, I was going to add on, like, we're very much built for scale. That's where win a lot of bake-offs, because anything can look good if you're just experimenting with a very small set of data, but being able to scale it to, like, some of our customers have uh, billions of inferences daily, like ad tech, e-commerce. They have thousands of models. Each one of these models has thousands of features and metadata and chat values. And then with embeddings too, they can choose to sample it. They can choose to upload all the data, because with a lot of the unstructured use cases, they're looking for a trend. They're looking for major aspects of the data and not just a single anomaly. They're looking for patterns. They're looking for kind of what clusters are emerging, what clusters are new. And so for that, sometimes they will sample the data or use all of it, because as we know, like, these can be very, very large.
Gotcha, gotcha, gotcha. There's a you said did you say bake off or big off? A big off.
A big off. um, a little accent coming out there. A bit of a bake off.
Oh,
So
bake off.
if
Well,
we
I thought it was actually so I assumed that you said bake off, but it would be kind of perfect if you said big off because it's like
yeah,
if you were like compare it like because it was specifically to deal with like who can handle the scale well.
yeah, break the scale. Whoever can, it's breaking the scale challenge.
Who can make 10 times as much cake?
Yeah.
100 times as much cake.
Is it?
Um, cool. All right. So, all right. I've, I think I've got a pretty good grasp on the Phoenix product, on Arize's commercial offering, and on these kinds of drift issues, model observability issues in general. A related problem, particularly with unstructured data being used in production, is bias. So I know that Arize has a bias tracing tool. Can you dig into like why this is important, how it relates to like model explainability, and how practitioners could be leveraging this to debug their models or maybe have models that are safer in production?
Right. I'll talk about the bias tracing tool, and then Xander, maybe you can give like an unstructured example of where you can start seeing poor actors or bad data coming through unstructured models by isolating data. But with our bias tracing tool, so when teams say, do you have explainability? What they normally want is bias detection, because explainability is great. Chat values are great. Knowing what features lead to model decisions is great, but it doesn't tell you anything about what the final decision was, the impact it has for that user. So looking at bias tracing and looking at it on different levels. So with bias, you're going to want to look at parity. So is my model making better decisions for this base group as compared to this sensitive group? Because if your model could just be, poor at making decisions, regardless of the group. So then your model's just bad, but it's not bias. And then sometimes your model's performance overall is really good, but not when you compare. Maybe you compare a certain demographic, a certain cohort to a base cohort, or a cohort where you have more data for, because you might have a minority and majority class. So by doing this parity comparison and using something like a recall parity or false positive rate parity, seeing the decisions you're making between groups is really key. And we actually have more information on that in the course and blog posts about how to measure and detect fairness in production. Because a lot of times it could come down, there's a lot of things that actually end up causing bias in production. Sometimes you say, oh, I'm removing all the data that relates to a protected class. But you could have proxies. You could have just not enough data on certain groups. You could have class imbalance issues. You can have, you can have certain biases in the data itself. And if you're training on a certain set, just being able to isolate where these biases are taking place. Because for parity scores, if you're looking at, say you're looking at the decisions you're making for a loan for women versus men, and you want that parity score to be as close to 1 as possible, because if it's as close to 1, your false positive rate parity is going to be good for one group and good for another group. But if you see that parity score, if you see if it's below 0.8 or above 1.25, that tends to be, if you're outside that range, you're outside of the 4/5 rule, which is, like I said, this is all new stuff, but that is implemented in Congress as a way to measure equal opportunity, and if teams are being essentially biased for jobs. So that's one way we measure it. So if you're way off that parity of 1, if it's like a parity of 0.1 or a parity of 6 or 7, looking more into the data is going to be key. And that, I know that's a little bit of a run on. It's just a very big topic. And
Sure.
it's not just measuring drift, and it's not just measuring performance. Like, there are special metrics in place around bias tracing.
Right. In addition to those special metrics, is it the case that these kinds of distribution monitoring or embedding monitoring, so like even going back to the conversation that we were having earlier, where I had this light bulb go off around what you were saying, where we could be using Phoenix for comparing training versus validation. And then you went into other examples of fine-tuned model versus not. Could we similarly, is it like, in addition to those special metrics that you just mentioned, Amber, can we just also additionally be like comparing the embeddings of like sensitive group versus not? Or am I?
Yeah, sure. So one thing that you can do, I mean, there's a lot that you can do here. One thing that you can do is easily imagine that we're dealing with like text output from a model, and you want to know, is the text output offensive or biased, or is it, you know is it actually producing some kind of bias against a certain kind of prompt? For example, maybe it's a prompt about, that has some kind of gender component to it. Is it producing output that's different based on gender? Right? Maybe that's a concrete example we could look at. Right? You're dealing with some kind of chatbot, right? Your input prompt has some kind of gender feature or gender, part component of the prompt, and you're looking at the responses. And if you actually embed the responses, what you can do is see if there's certain clusters, literally like clusters of your embeddings, the embedding space, right? Like clusters of your responses that are offensive or biased or, have some other kind of negative outcome there. And you can literally like look at those data points and color them by, uh, the gender of the input prompt, right? And visually see in the embedding space what's going on, right? So that's one idea. Like, the embeddings, because they contain this really rich information, are going to be very useful for understanding that kind of situation and use case.
Nice. Super cool. All right, nice. So we've got a clear idea of, I think, a lot of the key offerings that Arize has now, and this has given me, and presumably also our listeners, a huge amount of context around why ML observability is important, as well as how it relates to adjacent issues like what we were just talking about with bias and model explainability. So you guys have a lot of high-profile customers, companies like Uber, Spotify, eBay, Etsy. Are you able to share, without like obviously giving away anything proprietary about you or your clients that you shouldn't be sharing on air? Are there aspects of like your relationship with these big clients that you can dig into some case studies of how you were able to help with your solutions?
Yes, that's a great question, John. We see a lot of teams coming to us. Well, we see a lot of teams coming to us either because something went wrong in production, something went really bad. Models were down for a while. These are models that control websites, revenue, profitability, forecasting. They control how much product you're going to buy. And when those models go down or they drift or they decrease in performance, it has a cascading effect. So there's a lot of teams that come to us because something went wrong and they didn't catch it. It's at least a week to detect and fix an issue for most teams. And most of the time it's longer than that. Or we have teams that really want to be preventative. So some cases we see, going back to that retraining discussion we were having, when to retrain your model. And not everyone agrees at a company when they should be retraining their model and how they should be retraining their model. So having ML observability as a tool to justify retraining is going to be important. Some teams are using a lot of resources, retraining their model more frequently than needed, and it's not always the best case to just automatically retrain your model on data that you haven't really analyzed. And so being able to see the data, see what's going on, and say, hey, we don't have this, especially in large language models. You can see these new clusters forming. You can see, like Xander was saying, like prompt and responses. So being able to retrain models based on what you're seeing and making a justification for that. Machine learning engineers can use our dashboards, they can use our visualizations, put those in a kind of a PDF file and send that to certain managers. And we have seen that help teams a lot on creating a specialized training cadence. Another thing is for depreciated models. So essentially these models that you take out to pasture, what models are actually making a difference, what models aren't. And you can see those performances, you could track them over time. And that helps a lot of teams. The more models teams have, the more complicated their process is. And that teams stems to be where Arize really shines. For teams that have these models that are 3 or 4 years old, a lot of times they don't have the original members on the team who built these models. So helping to maintain them without knowing the source code, without having to change a lot of things up, you could tell, is this model working or not? And just by implementing it and having it in Arize, knowing when models are failing, and version control. So that's a big thing that Arize offers. Like when you're coding, you want to version control your code. Teams that we work with often version control their models, and then they can compare versions of their models. Just like we were saying, you could test production and training, you could test validation sets, you could test any 2 data sets against each other. You could also test model versions against each other and see which ones are performing better. So a lot of times what we see is a tool for the machine learning engineer to assist with their job, their workflow, and to catch issues ahead of time, but they can make justifications and tie that back to business profitability and business metrics. another big part of our survey was teams saying, business executives have a hard time quantifying the return on investment they're getting on AI. One of our customers said they spent 10 billion on AI solutions. They don't really know how it works or if it's even helping the company. All these companies will remain nameless, but we are seeing this happen where they don't want to not implement the latest technology, but they don't really understand if it's working or if it's actually improving their profitability for the cost that involves implementing it. And then, like I said, the other big part is scale. So Spotify recently gave a talk on how they are trying to manage their massive amount of embeddings in production with Arize. As you can guess, Spotify has all kinds of embeddings, and these are audio, these are text, there's search and retrieval. There's a lot of algorithms going on and a lot of personalization and real-time aspects that are happening. So the integration of all those models, the embeddings, the scale, I think those are the most important aspects when thinking of an ML observability solution, because trying to do all that in production while trying to build new models and do everything else that a machine learning engineer is supposed to be doing can be very difficult. So like having something in play where you set it up, you can check on it, but you know if it's doing fine, it is really key for a lot of teams.
Awesome. Yeah, those were great examples. Even the ones where you couldn't name the company
Yeah.
specifically, that really colored how useful a platform like this is, especially at the scale that these companies are dealing with. And then super cool that you're able to give that Spotify example in particular. Yeah, it's crazy to think how many embeddings they must have. Like you say, over like they have there's something like 100,000 tracks uploaded to Spotify a day, and apparently a lot of that's actually AI generated. Like it's
Yeah.
like
It's AI feeding AI tracking, like it's pretty crazy.
Nice. All right. So we've talked a lot about Arize, machine learning observability in this episode, but I haven't let the audience really get to know either of you as individuals. So I've kind of got a last topic here for them to learn a little bit about you. So, Amber, you studied astrophysics. Xander, you studied math. And you also both had different roles before you got into what you're doing today. So maybe just give us a little bit of a taste of how you transitioned into what you're doing today. So Xander, you're a developer advocate, which is a kind of role that I think we're seeing more and more in startups. So, related to working directly with developers, answering their questions, developing community, coming onto podcasts. So we see these kind of developer advocate roles in cool, fast growing startups like Arize more and more. Amber, your role I had never heard of before. So ML growth lead, machine learning growth lead. So you're going to have to dig into like exactly what that means. But yeah, so for each of you in turn, maybe we can start with Xander. Let us know like how you became a developer advocate and why a listener out there might be a perfect fit for a developer advocate role themselves.
Yeah, that's a good question. So I guess let me backtrack too, and just because actually this is my very first time ever doing this kind of role. I've been doing this dev advocacy stuff for like 8 months, and actually before I joined Rise, I actually did not know what a dev advocate was. So for anybody out there who doesn't know what it is, the basic idea is I think of it as like kind of two components. Part of it is evangelism. So as you said, going on podcasts, like you know, um, I spoke to a really well respected dev advocate in the field, and he basically told me you need to like live and breathe the you have to like convey the passion for what you're building, what the team is building to the audience, and convey the need, right? So evangelize the product, right? That's part of it. And then part of it is like being a pair of boots on the ground that is in touch with the community, kind of like the first person who a user of an open source product is going to talk to, and be a point of contact for the community, right? So if those kind of things appeal to you, like it's definitely I think a good career to consider. And in terms of how I got into it, my background, previously I was working as a machine learning engineer at an early stage company. and we actually died. So it was actually a smaller startup than Arize. Worked there for like 2 years. We really fought super hard, and we died. We couldn't raise. And when I kind of took a moment to understand why did we die, really the thing for me was that we were pretty heads down building stuff, and it turns out that the stuff that we built didn't have a market, right? It didn't have a strong market. We didn't achieve product market fit. And that really became this moment for me where I wanted to evaluate career-wise, like, how could I prevent that from happening again? Because it was very painful. And for me, the answer was, like, I just need to be like really engaged in the community and really in tune with the community, and for me, like, part of it is just like being a conduit between the company and the community as a whole.
Very cool. Nice explanation there. And yeah, you certainly got an ear to the ground now and can keep an eye on the trends. And it also seems like you've identified a company that has a great product market fit. So
Yeah, yeah.
nice. Amber, the
Yes.
floor is yours.
Awesome. And I will just say my role changes all the time. I went from academia to industry in 2018, and since then I've been a AI program director, an AI PM, head of AI sales engineer, machine learning engineer, and ML growth lead. And I think that's one of my favorite parts of doing that and being in tech is that you can try out these roles. You can see what you like, what you don't like. And I'm always curious about different roles and what folks are doing. And that's really what led me to growth, because I think it's one thing to be kind of heads down building the product, which I really do enjoy. But, what Xander said of like finding that product market fit and helping folks solve problems is really where I want to be. I want to solve those pain points we see for customers. And the growth aspect and being part of the growth team at a startup is incredibly important for word of mouth, for funding, for people getting their hands on the product, and for helping solve real world problems. And so the growth aspect is keeping in mind, are people using our product? Are they using open source? Are they using the platform? Are they staying engaged in it? Like, do we have activation? Do we have retention? Do we have people in our open source community talking about issues and ML ops that they face? And for me, I really like connecting with folks. I like giving talks. I like doing workshops, doing events, and having conversations. Like, John, we met from, an event, and that to me is all part of growth, like getting people to understand what Arize is, how to pronounce it, what ML observability is.
Arize.
Yeah, how do
Ah,
you say? So making sure that people kind of understand that they're even having issues in the first place. Like, what we talked about earlier about monitoring versus observability, about retraining on an arbitrary amount of time. Like, they don't realize these things, aren't as they seem until you kind of pull the veil up and say, like, are you struggling? Like, do you know if your users are churning? Do you know if you're maximizing the profitability of your models? And that's what I find really cool, because for a lot of teams a few years ago, when I started, ML observability was a luxury. Like, oh, that's nice to have, but we're focused in other areas. And now a lot of teams don't realize like how their models thrived without observability, because they're thriving way more now, and they feel safer about their models. Machine learning engineers feel better about putting their models in production, knowing that if something goes wrong, there are guardrails.
nice. Yeah. Yeah, it's an increasingly important area that everybody I think needs to be aware of if you're in this space. It's amazing to me that we haven't done an episode focused exclusively on ML observability like today. It was very obvious to me as soon as I met you that we needed to do this episode, and I'm glad you were willing to come on so quickly because when you describe situations like at Spotify, but this is even in much smaller companies,
Mhm.
machine learning models depend on machine learning models, depend on machine learning models in production. Like there's like these cascades. And so just one model drifting and having issues could mean that a user's experience really takes a nosedive.
Yeah.
So
One other
yeah.
interesting thing is at the ODSC, I judged a hackathon. And these were great presentations. People built amazing products. And at the end, when I asked, does it work? Do you know that it's working? Because they would show one or two examples. I'm like, how do you know it's working? How do you validate it? Do you have any KPIs? And that was all, those will be our next steps. But it's interesting because people are very focused on, getting this AI to work. And they think like, later on we'll figure out if this actually adds value. We can find value like right away for our customers. And I think that is the area of ML observability and LLM observability that Arize is really focused on.
Nice. Very cool. And yeah, I guess I should have done this right at the very beginning now that you mentioned the pronunciation thing, but Arize is spelled Arize or ZE
Yeah.
if you're in the United States. Awesome. Amber, Xander, this has been fabulous. I've learned a ton. And now our audience is very much aware of ML observability and its importance if they didn't know about it before. Before I let you go, I ask all of my guests for a book recommendation. So Amber, maybe if you want to go first.
Yes. I recommend Designing Machine Learning Systems. It's an O'Reilly book by Chip Puin. And I believe this is the one where our co-founder Aparna wrote either a chapter or part of a chapter on ML monitoring and how that could be put into place.
Nice. Yeah. Chip was actually on the show recently, episode number 661. And the title of that book was the title of our episode. So really important topic, super popular book, and super popular woman.
Oh yeah, Chip's great. She's also super nice. She'll be at a lot of these events. I recommend everyone says hi to her because she's a really great person to know in the space.
For sure. All right, Xander, what you got for us?
I'm currently working on a book that was actually recommended to me by the tech lead of Phoenix, called Measure What Matters. It's a book about KPIs and OKRs. And I think we use OKRs pretty aggressively on the Phoenix team. And it's been really interesting to hear about how some of the largest companies in the world and some of the most successful startups in the world drove their growth and honed their priorities using that particular system. So I'd recommend that one. Measure What Matters.
Cool. Yeah, great recommendation. All right. Thanks to both of you. Very knowledgeable speakers. Clearly know what you're doing. And I'm sure there's going to be lots of listeners who would like to be able to continue to learn from you after the episode. Xander, what's the best way that people can follow you afterward?
I'm not on Twitter at the moment, although I probably should get on Twitter. But for right now, I would say LinkedIn. Hit me up.
I do have a Twitter, Astronomer Amber, but I think LinkedIn is better. But if you have direct questions, you can join the Arize community Slack and just Slack me in that community. I'm talking with community members every day.
Me too. So I would second that point. Yeah.
Perfect. We'll be sure to include all of those links, your social media profiles, as well as the Slack channel, the Arize Slack channel, in the show notes. All right.
Awesome.
Thanks very much, guys. And yeah, we'll have to catch up again sometime with you to see how your ML observability and job title journey is progressing.
Awesome. Thanks, John.
Thank you, John.
Nice. Thanks to Amber and Xander for that highly informative discussion. In today's episode, they filled us in on how ML observability automates ML monitoring to catch and fix production issues before they become a big deal, how the various types of drift, for example, feature drift, label drift, model drift, can be tracked by comparing baseline probability distributions with production distributions, or in the case of unstructured data such as with LLMs, we can compare embeddings. They talked about how Arize's open source Phoenix library provides sophisticated tools for comparing embeddings, allowing us to compare LLM performance during training versus production. This allows us to monitor for drift as well as many other comparative use cases. And they talked about how the comparison of natural language embeddings allows us to compare whether sensitive groups are being treated differently by a model, thereby flagging where unwanted bias may be occurring. As always, you can get all the show notes, including the transcript for this episode, the video recording, any materials mentioned on the show, the URLs for Amber and Xander's social media profiles, as well as my own social media profiles at superdatascience.com/689. That's superdatascience.com/689. If you live in the New York area and would like to engage with me in person, on July 14th, I'll be filming a Super Data Science episode live on stage at the New York R Conference. My guest will be Chris Wiggins, who's Chief Data Scientist at the New York Times, as well as a faculty member at Columbia University. So, not only can we meet and enjoy a beer together, but you can also participate in a live episode of this podcast by asking Chris Wiggins your burning questions. All right, thanks to my colleagues at Nebula for supporting me while I create content like this Super Data Science episode for you. And thanks, of course, to Ivana, Mario, Natalie, Serge, Sylvia, Zara, and Kirill on the Super Data Science team for producing another exceptionally practical episode for us today. For enabling that super team to create this free podcast for you, we are deeply grateful to our sponsors. Please consider supporting the show by checking out our sponsors' links, which you can find in the show notes. Finally, thanks, of course, to you for listening all the way to the very end of the show. I hope I can continue to make episodes you enjoy for many years to come. Well, until next time, my friend, keep on rocking it out there, and I'm looking forward to enjoying another round of the Super Data Science podcast with you very soon.